Hi there! For this video, we'll be talking about imaginary numbers. So let's write that one down. Imaginary numbers. So from the previous video, we first recall that an imaginary number I is equal to square root of -1. And this is an imaginary number since this isn't possible, or there's no real value for this, since we know that this one, the radicand inside, must always be positive, since we can find a perfect square of -1. So let's explore this imaginary number. First, let's try to check I squared. Observe that I squared is simply square root of -1 squared, which is equal to -1 raised to 1/2 raised to square. So this one is equal to -1 raised to 2/2, or 2/2 is equal to 1. So this one is simply -1. For I cube, observe that I cube, we can write this one as I raised to 2 times I raised to 1. This is by laws of exponents. Since we know that I squared is equal to -1, from here, then we have here -1 times I raised to 1 is simply I. So we'll have here I. So this one is equal to -I. Let's try to check I raised to 4. I raised to 4, we can write I raised to 4 as I squared times I squared by laws of exponents. We know that I squared again is equal to -1. So this one is equal to -1 times -1, which is simply equal to 1. So we'll take note of these. So again, we have I is equal to square root of -1. I squared is equal to -1. I cubed is equal to -I. And I raised to 4 is equal to 1. How about I raised to 5? Note that I raised to 5 is equal to, you can write this one as I raised to 4 times I. I raised to 4 is simply 1. So we'll have here 1 times I, or simply I. And actually, you can verify that I raised to 6, I raised to 7, and I raised to 8 are all I raised to 6 will be equal to I squared. I raised to 7 will be equal to I cubed, and I raised to 8 will be equal to I raised to 4, which we know that I squared is equal to -1, I cubed is equal to -I, and I raised to 4 again is equal to 1. So given this, note that we can actually get all powers of I, say I raised to n for all n, and return it back to just in the form of I, or 1. So why does this happen? Well, observe that in these cases, like in this I raised to 5, we can actually factor out a I raised to 4 out here. And we know that I raised to 4 is simply 1. So if we have a large number, say I raised to, say, 41, then note that we can write this one as I raised to 40 times I raised to 1. And I raised to 40 can be written as I raised to 4 raised to 10 by loss of exponents. And we know that I raised to 4 is simply 1. So this would simply become 1 times I. Since 1 raised to 10 is simply 1, and this one becomes I. So that is the beauty in imaginary numbers. We can determine the value of all its powers and return it back to simply 1 or I. So we'll try to work on some examples like that. Let's have I raised to 33. Now the key step in this one is we first divide the exponent 33 by 4. So we'll have 33 divided by 4. This one is 8. So we'll have 32 out here. And this would be 1. Since 1 is already less than 4, we have remainder of 4. Rather, 1. Apologies. Remainder of 1. So, we can write this one as I raised to 4. This one raised to 4 raised to the quotient 8 times I raised to the remainder, which is 1. So this one becomes, we know that I raised to 4 is equal to 1. So this one becomes 1 raised to 8 times I raised to 1 is simply I. And 1 raised to 8 is simply 1 times I, or simply I. So this is the simplified form of I raised to 33. Let's have this next example. Let's have I raised to 402. For this one, note that, again, we divide 402 by 4. So 402 divided by 4. First have 1 out here. Subtract that, obtain 0. Bring down the 0, since it's just 0. Put 0 out here. Then we'll have your 0. Then bring down the 2. Since 2 is less than 4, then just write 0 out here. And then we'll have a remainder of 2. So we can write this one as I raised to 4, parenthesis out here, raised to 100 times I raised to the remainder 2. So this one is equal to I raised to 4 again is equal to 1. So we'll have out here 1 raised to 100 times I squared. I squared is equal to negative 1. Yep. I think I should put it out here. So we have I squared equals negative 1. I cubed is equal to negative I. And I raised to 4 is equal to 1. So 1 raised to 100, this one is simply equal to 1 times -1 or simply -1. So we have simplified I raised to 402. Let's have this third example. Let's have I raised to 787. So again, we divide this by 4. So let's put it out here. 787 divided by 4. This would be 1. 4 subtract 3. Bring down the 8. This one will be 9. This will be 36. Subtract 2. Bring down the 7. So we don't much have space out here. Then we'll have here 6. So this will be 24. Subtract. This will be 3. So we have a remainder of 3. So this one is equal to I raised to 4 parenthesis raised to 196 times I raised to the remainder 3. So this one is equal to I raised to 4 is equal to 1. So we'll have here 1 raised to 196 and I cube is equal to -I. So 1 raised to 196 is simply equal to 1 times -I, or simply -I. So that is how we deal with imaginary numbers. Now let's try to go back into dealing with this one. So recall that in the previous video, we know that we'll be needing an imaginary number or the imaginary number in solving this one, since we have a negative exponent out here. So to solve this one, first that we can write this, note that we can write this one as -4 raised to 1/2, and this one is equal to -1 times 4 raised to 1/2. This one is equal to, by laws of exponents, we distribute this one. So we'll have -1 raised to 1/2 times 4 raised to 1/2. And then going back to the radical sign, we'll have here square root of -1 times square root of 4. So this one is equal to square root of -1 is equal to I. And then square root of 4 is equal to 2. So this one is equal to 2i. So that's how we deal with the square root of involving a negative number. Note that we can also take positive negative out here if we are considering the secondary root, but in general we take the positive, since when we deal with radicals, this one is actually equal to square root of x is equal to square root of x squared is actually equal to absolute value of x. We only consider the secondary root, as discussed in the previous video, or the negative one, if we're dealing in equations and such. So let's have this one final example. Let's have the square root of -162. Again, with the same process, we'll have here -1 times 162 raised to 1/2. So this one is equal to, by noting that 162 is actually equal to 2 times 81, which is also equal to 2 times 9 squared. So we'll have here negative 1 times 2 times 9 squared raised to 1/2. Then by loss of exponents, distributing the exponent, we'll have here negative 1 raised to 1/2 times 2 raised to 1/2 times 9 squared raised to 1/2. So we'll have here this one, turning back to the radical sign, we'll have here square root of negative 1 times this one. Since we can simplify this one, we'll have here square root of 2. And for this one, note that this one out here is equal to 9 raised to 2 over 2, or simply 9 raised to 1, or 9. So this will become 9. Simplifying, square root of negative 1 is equal to I. So we'll have 9 square root of 2i. That is its simplified form. So before I end this video, here are some 2 exercises that you can work on. So first, we have simplify I raised to 2023. And the second one is simplify the square root of negative 147. So this is a good exercise to try and apply the skills and knowledge that we learned in this video. So that's it for this video. I hope you enjoyed it, and feel free to comment down your solutions and your answers to these 2 exercises. So that's it for this video. Thanks and have a nice day.